Hello everyone, a very warm welcome to my channel. Today we will be starting a new chapter, Atoms and Molecules, chapter 3, class 9, and I am Ashmi Arora. So if you like my video, please subscribe my channel as well as share my video. So let's start. What is the history of atoms? First, the most ancient Indian philosopher around 500 BC, it is almost around 500 BC when the ancient Indian philosopher named Maharishi Kanand. Maharishi Kanand postulated that all the matter, which is also known as in Hindi the Padarth, matter is composed of small particles known as Parmanu. All the matter is made up of Parmanu. All the matter, that is the Padarth, is made up of small tiny particles known as Parmanu. Next, the another philosopher known as Pakuda Katyayama. Pakuda Katyayama elaborated the statement further that if we combine all these Parmanu, then we get a different forms of matter. This is the main statement of another Indian philosopher, Pakuda Katyayama. Pakuda Katyayama stated that if we combine all these Parmanus, then we get a different forms of matter. Then another philosopher which plays a very important role in the discovery of atom, known as Democritus. Democritus suggested that matter is a nothing, but he states that the matter is derived from atomos, which means indivisible, which cannot be further divided, which means indivisible. And Democritus postulates that matter is made up of small indivisible particles which cannot be further divided. If it is atom, then it cannot be like divide into further small particles. It is indivisible. So the Hindi version of atom is given by Maharishi Kanand, and the English version of atom, which is derived from the word atomos, is come from Democritus. Clear? The first laws of chemical combination. In the first law, the law of conservation of mass, which is given by the scientist Antoine Lavoisier. What this Antoine Lavoisier stated under this law of conservation of mass, as the name suggests, conservation means to preserve. What is to preserve? This is mass. Means mass can neither be created nor be destroyed in any chemical reaction. Suppose we have A plus B. Right? So this is known as reactant and this is known as product and reactant, right? So what he said, that the mass on reactant side is equal to the mass on product side. This is the law which is given by the Antoine Lavoisier, that the mass on reactant side is equal to the mass on product side. And what is the easiest way so that we can equal the mass? If the number of atoms on reactant side is equal to the number of atoms on product side, then the mass will become automatically equal, right? So the mass which is present on reactant side is equal to the product side. We can neither create any additional mass nor we can destroy the already existing mass, right? So the mass can neither be created nor be destroyed. This Antoine Lavoisier further given one of the activity to prove his statement. And what was that activity? What he did, he took one of the conical flask, and inside that conical flask he put a sodium sulfate solution. Inside that flask, he put a tube. Inside that tube, he put a calcium chloride solution and just tied it with the cork so that no gas or the fumes after reaction gets come out. So completely airtight condition is maintained inside the conical flask. And then he observed the initial weight that comes out to be 300.23 grams. So now it's a time to shake so that all the test tube of calcium chloride get mixed up with the sodium sulfate solution. Then what will happen? He observed that the mass after reaction is equal to that of the initial one. The initial mass is 300.23 and after reaction the mass becomes equal. So he proved that reactant side's mass which is present on reactant sides is equal to the mass which is present on product side. Let's see how it happens. When sodium sulfate combines with calcium chloride, then what will happen? Then calcium sulfate plus sodium chloride is formed. This is positive, this is negative, this is positive, this is negative, right? So this calcium said that I am bored with my partner. I want to change my partner. So calcium combines with sulfate, means partner of second compound. Similarly, sodium said, okay, fine, I'll also change. So sodium, which is positive, combines with the negative part of the another partner. So in this way, we get a sodium chloride, which is salt, and calcium sulfate. So the initial mass on the reactant sides, which is 300.23 gram, is equal to the mass after reaction, which is also 300.23 gram. So no mass is destroyed and no mass we have created, any additional mass we have created. The mass becomes equal after reaction. So this is the law of conservation of mass, which is given by the scientist Antoine Lavoisier. Next law is the law of constant proportion, which is given by the scientist Joseph Proust. What this Joseph Proust states that in a chemical substance, the elements are always present in a definite proportion by its mass. This term is very important, by its mass. Suppose we get a water, whatever the source of water, suppose we get a water from pond, from river, whatever is the source, we get a water which is a compound. So in this compound, the mass of oxygen is always present in the ratio of 2:16U, which if we simplify, it comes out to be 1:8. So whatever is the source, the mass of hydrogen and water combines in a very fixed definite ratio by its mass, then it is known as the law of constant proportion. By its weight they will combine in a very definite ratio, then it is known as the law of constant proportion. Let's take one more example. If I'll talk about ammonia, then the mass is 14:3. Then this is ratio will be definite by its mass. So whenever I want that two compounds, nitrogen and hydrogen, combines to form ammonia, then it will always these elements combine in that 14:3 ratio, so that we get a ammonia, right? Let's take another example, carbon dioxide. If I want one element carbon and two element of oxygen combines to form carbon dioxide, then what is the ratio? Let's calculate. 12:2 into 16. This comes out to be 12:32, which can be simplified as 3:8. So whenever the carbon dioxide combines, then carbon and oxygen has to combine in a fixed ratio of 3:8 by its mass. This is the law of constant proportion, which is given by the scientist Joseph Proust. So next most important scientist is the John Dalton. Dalton proves that this was all the philosophical approach, like Maharishi Kanand and Democritus, whatever they postulated, this was all about the philosophical approach. But we need a scientific approach at the end of 21st century. So to give that scientific approach, Dalton plays a very important role. What he did, Dalton provided a Dalton atomic theory. Means whatever the philosophical approach is given by the earlier scientists in the ancient time, to convert that philosophical approach into scientific approach, Dalton plays a very important role. As well as he also explained these two laws in his theory in a more better way, in a more scientific way. So let's study the John Dalton atomic theory. Next theory is Dalton's atomic theory, and the six postulates. Postulates means nothing but it is a facts which is given by the scientist John Dalton. Let's see what the John Dalton, according to the John Dalton, all the matter, whether it is compound, element or mixture, is made up of small particles known as atoms. So the first postulate which is given by the Dalton, the first postulate that all the matter is made up of tiny particles known as atom. So Democritus also said the same statement, that atom is derived from atomos, which is indivisible, and the atomos means indivisible. The same statement which is put into his theory also, that the atoms are indivisible particles. Like if we have this atom, like it is a kind of a, let's assume that it is a sphere in shape, then we cannot divide further into smallest particles. It is indivisible, we cannot divide further. Next, the atoms can neither be created nor be destroyed in any chemical reaction. This is the statement which we already study in the law of conservation of mass, that if the number of atoms on reactant side is equal to the number of atoms on product side. This is what we have studied in law of conservation of mass. And what the John Dalton said, he just picked that law of conservation of mass and put it in his theory as a second postulate, that atoms are indivisible and cannot be created nor be destroyed in any chemical reaction. The third point is, atoms of given element are identical in mass and chemical properties. Like if we have nitrogen, all the atoms which is present inside this nitrogen, these all atoms have same mass. They having the same mass as well as carrying the same chemical properties which is present inside this element of nitrogen. Next postulate is, atoms of different elements having different masses. Like if we have carbon and we have oxygen, then the atoms which is present inside this oxygen is somewhat different from the atoms which is present inside this carbon. So the atoms which is present inside the oxygen having a different masses to that of this carbon, as well as carrying a different chemical properties is different from that of this carbon, right? So different element having different masses and different chemical properties. Atoms combine in the ratio of whole number to form compounds. Like if you want, this law is already given by the second law, that is the law of constant proportion. If in the case of carbon dioxide we want to combine carbon and oxygen, then it has to be in the definite ratio into 3:8, which we have already discussed in the law of constant proportion, that it has to be in a small whole number to form any compound. The next law is the relative number and the kind of atoms are constant in a given compound. Like if I want to form carbon dioxide, then I have to take two atoms of oxygen and one atom of carbon, right? If I don't have one oxygen, then the compound may get altered, right? So the kind of atom, if I alter the number of atoms, if I remove one of the oxygen, then the compound gets entirely becomes different, right? So the kind and the number of atom has to be constant for any definite compound. But the Dalton atomic theory has a lot of drawbacks. Let's discuss the drawbacks also. The first drawback, Dalton said that the atoms are indivisible. While you will study that atoms can further be divided into protons, neutrons, and electrons in the next chapter. Was the first drawback, right? Atoms of a given element are identical in mass. See, I have carbon. These are the two same element, but they having a different masses. Same element can also having a different masses, but the Dalton said no, same element always carrying a identical masses. But here you can see that carbon is the same element but having a different masses of 12 as well as 14. So this was what which known as isotopes, which you will study in the later on chapter. So this is the next drawback of this theory. The next drawback is different element having a different masses. No, calcium and argon, they having a different element but they having a same mass. Calcium also has a 40 and argon also has a 40. They having a same mass. So different elements may carry a same mass. This is what is known as isobar. Isobars means different elements having a same mass, but Dalton said no, they having a different masses. So this is also another drawback. He said that the atoms combine in a whole number ratio, but if you see the case of sugar, which is C12H22O11, we cannot simplify further to any whole number ratio. We cannot divide these number to simplify it, right? So this is not a case of whole number ratio. So this is also another drawback of this. So you can see that Dalton atomic theory has a lot of drawbacks, and you will study how to overcome these drawbacks in the later on chapters. So thank you so much. If you like my video, then please subscribe my channel and share my video. Thank you so much.